Today we're going to talk about classifying polynomials and adding and subtracting polynomials. So this is the first lesson in the brand new unit. So you should have found your notes posted for you to print out, and you can just fill in yours as we go through. I'm not going to do every single example just to save some time. I'm going to go through and do the even numbers. And if there are any in the examples that I don't cover that you'd like to discuss, by all means, you can always contact me to discuss them. So first thing we need to talk about with polynomials, the definition of a polynomial is really two or more terms that are connected by plus or minus signs. So some examples, again, I could just, make these up. I could have x squared plus 3x plus 5. I could have y minus 2. I could just simply have a single value like 12. That could also be considered a polynomial. But anything like that, things you don't want to see in polynomials are multiplication and division. Okay, so just so that you know there. Now, standard form is what we try to write all of our answers in. And that's when you're going to start with the highest power of your variable and work your way down to the smallest or no variable. So in the first set of examples, again, I'm just going to look at the even here. To rewrite these in standard form, you want to look at all of your powers of each term. Here I have a problem with 4 terms. 1, 2, 3, 4. And I see that the variable used in this particular problem is a k. So here I have a power of 2 on the k. Here I don't have a k at all. Here I don't see a power, but again, I always know if I don't see 1, then it is a 1. So I can put a little 1 in there. And in the last term here, I have k to the 3rd power. So out of all of my powers of k, clearly 3 is the largest power. So if I'm going to write that in standard form, I want that k to the 3rd term to come first. Then I want to work my way down. Next power down would be a 2. And it's a positive, so I'm going to put a plus sign in front of that k squared. The next power down would be a power of 1. I look to the sign in front. I see it's a minus, so I want to keep that minus. And then last term, all that's left is a positive 64. So now I have a polynomial of 4 terms, and it is in standard form because highest power is 3, down to 2, down to 1, and then down to no variable at all. So looking at example 4 here, again, first term doesn't have an a variable. So I'm going to skip that. I see my next term has an n to the 3rd. My last term has an n, and again, not seeing anything for an exponent means a 1 is now your exponent. So out of my exponents, 3 is my highest, and there's a minus sign in front. So I want to keep that minus sign, which is now considered a negative, with the n to the 3rd. I don't have an n squared, so I can skip that. My next power of n is the power of 1, so I'm going to put a plus n. And the only thing left in the problem is this positive 24, which I will write as a plus 24 all the way at the end. Example 6, here I have 1, 2, 3, 4 terms again. And in this case, this is 2 variables. So when it gets to 2 variables, which doesn't happen often, you want to consider it alphabetical order. So concentrate on your C's, then go to your D's, and then finally your constants or any term without variables. So looking at C first, because it comes before D in the alphabet, I have a C to the third. Don't have any C's here. I have a C to the second here. So out of those two exponents, 3 is bigger. So I'm going to start with that minus C to the third, or a negative C to the third. I'm going to jump over to the last term because that had a C to the second. Then I'm going to go back to my D that's left, which is a positive 5D to the third. And the last thing left is this positive 13, which has no variables at all. Okay, so that's just writing it in standard form. It's just customary for us to try and keep things in an order that's easy. All right, so classifying polynomials, there are ways to classify by both degree and number of terms. Degree is simply the highest exponent on a variable. And we have names for them. For example, if there's a degree of 0, that means there is no variable. So if you paid attention just earlier in this video, I already called that as a constant. A degree of 1, that's where we had a power of 1. In this case here, we've also talked about something earlier in the year of degree 1. That's linear. Just like our linear equations, y equals mx plus b. X always had an exponent of 1. So that's why they were linear. 2, if your highest power is 2, that's called a quadratic. 3 is called a cubic. 4 is called quartic. And I usually tell people, think 4 quarters make a dollar. So if we have a degree of 4, you want to think of quarters or quartic. The number of terms, again, we can name polynomials by the number of terms. If there is just one singular term, think of a prefix that means 1. And you may have come up with mono, which would be absolutely correct. For a number of terms, if it's one term, we call that a monomial. For for 2 terms, now you want to think prefix that means 2, like a bicycle. So therefore, this should make sense that if I have something of 2 terms, that would be a binomial. 3 terms, maybe you're already catching on to this, that would be a trinomial. And then 4 plus, anything higher than 3, we call that all the same, and we use the prefix poly, which means many, so we call that a polynomial. So in the next set of examples here, if I just ask you to name the kind of polynomial. So in number 8, I have 1 term here. All right, it's just a negative 2x. The negative 2x is not connected to anything else with plus or minus signs. So 1 term makes it a monomial. And the power of x, I don't see 1, so I know it is 1, which means my degree is 1, and that is now linear. So this is a linear monomial. For number 10, I see the highest power is 2, so that's a degree of 2, which makes it quadratic. And if I count my terms, 1, 2, 3, that makes it a trinomial. Example 12, looking at the powers of m, 4 is my highest power, which would make that quartic by its degree. And 1, 2, 3, 4 terms makes it a polynomial. So this clearly has a quartic polynomial. Okay, So that's classifying polynomials. Now let's talk about adding and subtracting. And really, you've done this before. We just called it something else. We called it combining like terms. So that's exactly what we're going to do here. If you see anything with parentheses, the first thing you need to do, okay, sorry for the pause or disconnection in the video. That was my dog freaking out over a squirrel in the front yard. So, okay, let's keep going. So again, back to addition and subtraction. If you see parentheses around any of the problem, you really want to get rid of those first. Now what you're going to see with adding, super easy because you can just eliminate them. Everything stays exactly as is when we're adding. Signs don't change, anything like that. So really, the only thing I am going to do here is I'm going to rewrite them in standard form, just because I find it's easier to put the pieces together. So in this first polynomial, I see my highest power is an x squared with the minus in front. So I'm going to rethink that as a negative x squared. Next one in that polynomial is a positive 11x. So I'm going to write that as a plus 11x. And then positive 13 is my last one. Now I like to line them up vertically. All right, you don't have to do this. It's just something that I find is easier to put them together. So now when I'm looking through my second polynomial here, I see an x squared and I'm adding, so signs aren't going to change. So underneath this first x squared, I'm going to put a positive 2x squared. I see a negative 5x, so that's going to come next. And then my negative 23 will come last. And now when I combine these, I can just go straight down the columns, just like you did in elementary school when you first learned to add larger numbers together. So adding my x squared terms together, I have a negative, and again, no number there means there's a 1. So negative 1 plus 2 is going to give me a positive 1x squared. My x terms, positive 11, negative 5, put them together, gives me positive 6. And positive 13 and a negative 23, put them together, gives me a negative 10. And there I have my answer to the addition. With subtraction, your first polynomial isn't going to change. But when there's a minus sign in front, now you want to think of distributive property. It's almost like there's a negative 1 squeezed in there. So we really need to distribute that negative 1 through that second quantity. And then, nice part, it becomes an addition problem. So my first polynomial isn't going to change. I'm going to leave it as 4x squared and positive 5x. But now distributing through here, here's my x squared term. Negative 1 times positive 3x squared is going to give me negative 3x squared. My 7x as a positive gets multiplied by negative 1, now becomes negative 7x. And my positive 1 at the end, being multiplied by the negative 1, gives me a negative 1 all the way at the end. And now we're right back to adding our columns. So when I combine my first columns here, I'm going to get a positive 1x squared. Combining my x terms together, I'm going to get negative 2x. And the last column, there is nothing to put with the negative 1, so I just keep it as a negative 1. And now I have my answer to the subtraction problem. Okay, so let's go through and do the evens here. And then at that point, I think you'll have more than enough to go ahead and try the homework. All right, here we go. So in number 14, I see k squared, k, and then just a regular number. So that's good. It's already in standard form. I'm adding, so nothing changes. So I'm just going to go ahead and move this one underneath. So I'm going to positive k squared, positive 9k, and a negative 3. And now combining my columns, I have 2k squareds positive 5k, and a positive 4 for my answer. Number 16, again, it's adding. And here we have two different variables. So again, remember, alphabetical order. So x comes before y. That first one looks good because I'm adding. I can just ignore these parentheses. I'm just going to rewrite the positive 3x under the 9x, the positive 2y under the negative 5y, and then I'll think of the negative 7 out on its own. So combining my columns, it's going to give me 12x minus 3y, because negative 5 and positive 2 together, and the negative 7 is all on its own. 18, another addition. So my first one looks good the way it is. Second one needs to be reworked a little bit here as far as the order, because now my first one, the highest power was 2. The second one, the highest power is a 3. So I want to make sure that when I bring this over, I'm actually going to put the 3a to the third out on its own in front. This second polynomial doesn't have a squared term, so I'm just going to put a plus 0a squared, just so that I know there weren't any. My negative 5a here, well look, I actually have an a minus 5a. These can already be put together as negative 4a. And now I write the negative 4a over to this side. So now combining my columns, 3a cubed is the only a cubed. My a squareds together, and my a terms together, and we're good to go. Now we're to the subtraction. So again, you want to think negative 1 is going to be multiplied in through that second group. So 5r and 2s are good the way they were. My 9r is actually going to become a negative 9r by distributing. And my negative 11s is going to become a positive 11s once I distribute that negative 1. Put your r's together, gives me negative 4r. Put your s's together, positive 9s, and we're good to go. 22, negative 1 comes in to all three of those terms. So 3m squared looks good. Here my m squared is actually going to be a negative 1m squared. 2m is going to become a negative 2m. And negative 5 will actually become a positive 5. Now combining, we have 2m squared, positive 5m, and a positive 4 when we put them together. 24, taking the negative 1 into that second quantity. My 2y is going to become a negative, and I'm going to put that under the negative 3y. My negative 13 will become positive 13, and I'm going to put that out on its own. And my positive 5x will become a negative 5x, and I'll put that underneath the 8x. So now combining, my x's give me 3x, y's give me negative 5y, and I tack the 13 on to the end. 26, the last one. Now it's saying subtract this quantity from this quantity. Whenever you're given a subtraction in word problems, you want to reverse. So it's really, we're starting with this w to the third plus 6w squared minus 2, and then we're going to subtract 2w squared minus 5w plus 10. So this is actually where your negative 1 is coming in. So when I do that, I didn't have a w cubed. I can leave that space alone. My negative 2w squared will go under the 6w squared. My negative 5w, well, this one didn't have a w. So really what I could do is push this negative 2 out and make this a 0w. And I know that's a little tough to read there. But 0w, so my negative 5w will go under there. My negative 10 from distributing will now go under the negative 2. And now I have 4 different columns to go ahead and simplify. So w to the third was its only 1. My w squared is going to give me positive 4. My w's are going to give me negative 5w. And my constants will give me a negative 12. Okay, so that's where this video is going to end. Try your best with the first homework assignment, and we will start the next lesson in a couple days. But again, feel free to send me your messages, and we'll see each other again real soon. Take care.